So, good job, Mrs. Talbot. Um, I think I actually got sick from being in the hospital. I wasn't in the hospital. I was just in the hospital, literally like just the preposition in the hospital. I think I got sick from a sterile environment or from Mr. Talbot, either one. Okay, anyway, I'm fine. I'm fine. It's good. It's good. Good. It's good. Caffeine, Sudafed fueled lecture. Here we go. Okay. This is actually really well placed because one of the things that I know you all have forgotten is how to do linear regression and two variable stats and all of the interpretation sentences from chapter 3. And that's actually the first thing we're going to do is review chapter 3, which is going to be great. It's a really good idea. Unfortunately, it's going to be annoying, but you all need it. So here we go. Confidence interval for slope. How do we start a confidence interval? Beautiful. Blank percent. Confidence interval 4. Okay, now this is interesting. So slope has two symbols. The sample slope is little b, and the population slope, like the theoretical perfect slope, is capital beta. So this guy is capital beta, and this one means the true slope or the population slope. And you guys remember in chapter 3, we did y hat equals a plus bx. That little b is the sample slope. So we were already working with sample slope back then. You just didn't know. Anyway, confidence interval for and these two things will be the labels on the axes. So y-axis, x-axis. So yards to amount of cats. I don't know. Whatever variables are on the axes. Okay. So percent confidence interval for the true slope beta relating whatever the y is to whatever the x is. Can you guys tell me what the state would be for the problem that we have on our resource page? So let's just pretend, hold on, we're doing it later, but oh, it's 95%. Okay, take a look at this graph right here. 95% confidence interval for the true slope beta. You don't know that yet. There's going to be a number there relating yield per plant to fertilizer. Not a big deal. Okay, now the plan is pretty much the most irritating plan that you could have. Notice I have 5 conditions. Great. Anyway, this is called a T interval for slope beta. And just so you know, slope intervals and slope tests use T and T star, not Z and Z star. So just like means. I want you guys to tell me what you think any of these letters mean. So I made this up. Actually, the book might have made this up as a way for you to remember the 5 conditions. The word liner, L-I-N-E-R. Do you have any idea what any of them might be? Just from your other conditions. No, but R stands for. What are your other conditions we usually use? What's the first one? Random, yeah. Okay, Anyone have any other ideas? Yes, independence. And what do we lovingly call the independence condition? What's the same thing as an independence condition for us? 10%. Nice. Great job. Okay, now think about what you're doing for the rest of them. E, you probably won't get. I don't think you guys are going to get E. That one's probably not that easy. But if you're talking about linear regression, what might L be? Linear. Okay, now I'm going to ask, this is going to be the most impressive thing. If somebody can remember this, I'm going to be super impressed. Does anybody remember what we would normally say for a residual plot has no pattern and? This is like October, November. Even scattered night. Okay, so the what we said in chapter 3 was no pattern and even scatter. And that's the E condition. Except for they don't call it even scatter. They call it something more sophisticated. It's called equal standard deviation. Equal standard deviation is the same thing as even scatter. Okay, so what are our three conditions in regular confidence interval test? Random, 10%. What's the last one? Large counts. And what are you checking for in large counts? Normality, right? You're checking for the population to be normal. So that's what the N is here. Um, so how do you check for normality? Are you getting the idea that you're going to have to be given a lot of stuff to do these? You have to be given graphs and stats and stuff, but that's why I gave you that whole resource page of crap. So you have to have all this stuff or you can't do these. Okay, check histogram or and this was the other one you guys were saying, no extreme skew or outliers. Okay, we are going to go back through these conditions when we do the example problem. I'm hoping that it will all, it's really not that different. I don't know why they broke it into five. It's fine. It's fine because you've got the word liner. That's going to help you remember that there's lots and lots of conditions. Okay, now the do step. So first thing I want to say is that this is a confidence interval. This is really good for us to go back to talk about confidence intervals. You guys realize that whenever you take a gap in learning and then go back and learn it again, it only strengthens what you know. This is the confidence interval formula: statistic plus or minus critical value times standard error of statistics. So we're going to write that here. Because I really want you to be relying on that formula sheet. You guys know where you can find that, right? On the front page. Okay, so now flip to the other side of the yellow sheet. And at the bottom, there are the formulas that are used for this. However, we don't really use them. I can tell you that these are the formulas for slope. I can also tell you that you're never going to look at this spot again. I have never seen a problem where you've had to calculate any of these things. They're always given to you. So that's really super cool that they put this on here. It's not useful at all. So we're going to go back to our common sense knowledge. What is the statistic here? The statistic is the sample slope. So little b, lowercase b, and population, the true slope is the capital B beta. So slope, let's make a little arrow. Plus or minus, and these problems are all t intervals. So this would be t star. Do you guys remember how to find t star? Let's put it over here just so that hold on. Hey, I made it that long without messing up. Also, I think this is the good pen. I want to remind you that T star and Z star are absolute values. They are always positive numbers. And then the other thing that you need to know is that degrees of freedom is different for slope. It's actually n minus 2, not n minus 1. Why is it n minus 2 instead of n minus 1? It's because you have to subtract one freedom from x and one freedom from y because they're two variable situations. So one for x and one for y. Okay, so back to here, we have our statistic, which is our sample slope, plus or minus critical value is going to be t star. Just a reminder, that's how you calculate t star. Standard error of statistic looks like this. Standard error of the slope, SEB. And this, you're not ever going to calculate. They gave you a formula for it. It's a hot mess. This is going to be from the regression output that's given to you in the problem. So in that giant stack of stuff that they have to give you to be able to do the problem, standard error of the slope is going to be one of the numbers. And I'm going to remind you of all of those things when we get to the resource page and example. But the first thing we're going to do before we start our example for the confidence interval, we're actually going to do chapter 3 review, which is remembering the sentences from chapter 3. Also, I'm hoping that this will take me until about, my goal is like say 9:25. Then I'm going to tell you my story about the last freaking 4 days in the Talbot house. And then I'm going to let you guys work on your MCQs or R&T problems or whatever you need to work on, is my hope. Okay. So next question, do you guys know, anybody know Maya Chakrabarty? Last year, I don't know if you know what kind of student she is. I'm assuming that if you know her, you know what kind of student she is. Last year, she made 2 Quizlets, one for all the interpretation sentences of the whole year, and another one for all of the state, like to go through and figure out how to start each problem. I actually ran across them when I was looking up this stuff. I'm gonna post those on Google Classroom for you. I'm sure they still work. But that will help you with this bit here, which is these old interpretation sentences that I'm sure you've forgotten. I'm really happy we're going over them. Anyway, okay. So I don't know. She's amazing. Like her little group of 3 friends. It's like Alyssa, Lydia, Maya, super cool people. Anyway, they put all of this work into these. So I'm gonna make sure that you guys have them. Okay. Let's try to go back to our chapter 3 brain. The first thing we need to do is take a look at this. This is the regression output I was referring to here. Be like, okay, Mrs. Talbot. Now CP&M, I stole this problem from CP&M because I really liked how they gave you everything that you needed, and it was like an actual word problem. But you know how CP&M is, they're goofy. So they said back in the wording of the problem that that somebody spilled coffee on it. Okay. And the reason that they said that is because there are certain numbers in the problem that you don't use. The ones with the coffee on them I never end up getting used. So there it's trying to help you figure out what numbers to use because there were so many. So that's just CP_M being silly. Does anybody remember which number is A, the y-intercept? Yep, 0.85. Okay. And the reason that you can tell is because it says constant. So constant is just the number that's being added or subtracted. It doesn't have a variable on it. So this is A, which is the y-intercept. Okay. And to interpret the y-intercept, we say, first of all, we're going to say that it's 0.85. It's 0.8500, but that's okay. 0.85 at 0 grams of fertilizer. We predict 0.85. Oh no, I wrote out, just gonna say kilograms like that. We did not read the problem properly as we should have, but this problem is about coffee beans. That's why they spilled coffee on the, anyway, it's very silly. And you could think about the y-intercept being the coordinate 0, 0.85. So at 0x, we predict 0.85y. Okay, back to your resource page. Which one of the numbers is the slope? The one below it. Great. So put a little b equals there. You can tell because it's next to the variable, which is showing that that is changing as the fertilizer changes. Okay, how do we interpret slope? For every increase in 1 gram of fertilizer, we predict. Okay, then you think to yourself, is my slope positive or negative? Positive. Okay, those two I think are pretty easy. Not to remember necessarily, but once you remember them, they're not that hard to write down. The S is actually harder, I think. Go back to your resource page, find S. It's just labeled S. So we don't have to have a which one is it question and answer session 0.6841. The question is here, Do you remember what S stands for? Of what? You correct. Yes. So remember, we drew in the residuals. Those were like vertical segments to the regression line. And this is how like a measurement of how long those are. So how close the dots are to the line, basically. Not to be confused with the standard error of the slope, though. So anytime you have a standard deviation, there's got to be some sort of typically varies in there. So if you break this down into like regular person language, it's the average residual is about 0.6841 long. So the distance between the points and the line. That one's rough, I think. I like the other two much better. I don't think you're gonna love standard error of the slope. No, you're not. However, R isn't bad. Okay, I'm at the bottom of my page. I'm gonna just pause here for a second, just in case anybody's still writing. Then I'm gonna flip my page over. We have two more to do, and then we're gonna do the confidence interval, and then we're done. The next, she's lengthy. Okay, here's the good news I want to pass along. I know that this is overwhelming at the moment because we're doing a lot of review at the same time. Um, However, when I teach you how to do the hypothesis test, we're going to use the same exact example, which means that all of this stuff is already done. So the 12.3 B notes will be much easier because all of the conditions will be done. This will be done. We're getting a lot done today that we're not going to have to do over again, which is great. Okay. I don't know how I'm doing on my timeline, but we're in the Might just use some solder.
No, she wasn't in the other.
So I might just ask Miss Sutter. I can, but I have to, I don't know if that's okay with Miss Hydell.
Okay.
But I'll ask her. I'll try to, Miss Hydell is completely swamped right now, so I don't think she's gonna care.
Okay.
My hackles are leaning toward it's fine.
Thank you.
How do you know when he's you know, isn't it poison? Yeah, okay. And so it's the stuff with the ground and it's gonna go on. Yeah, that's right. It's not the same. I didn't know there was one.
James, do you have anything? Jeremy, Jeremy, Jeremy.
Yeah. Okay.
Are you guys close? Okay, just real quick before I start back up again. So, do you guys recognize this from the do step? This is that magic number that you need to locate to put in the standard error of the statistics spot. And let's just use common sense. You're like, this is tough. You're crazy. Which number says that it's the standard error and lines up with the slope? Which number says that it's a standard error and lines up with the slope? Nice. I said it that way because I don't want you to memorize it. I want you to be like, standard error of the slope. So that is standard error of the slope is that guy right there. Okay, now real quick, we don't need this anymore. The regression output, you're not going to use that number ever. And remember on r squared, you can square root r squared to get r. But remember on that, you have to check the sign because r can be positive or negative. R squared is always positive. Do you know how to get the sign? Check the slope. That's just chapter 3 review. Why on earth does it go from capital R squared to lowercase r? I have no idea. I think that would be a great question for me to ask Chad when I have time. Anyway, okay, so move to this side over here. All right, so standard error of the slope. This sentence is annoying. I'm just gonna warn you ahead of time. Standard error of the slope is 0.0094. Oh, thank you. I got too much going on over here. Okay, now this is supposed to start if we take many random samples of size blank. This particular problem is random assignment though. So I'm going to say if we repeat the random assignment many times. So if you remember back in the day, it used to say, if we take many random samples of size n equals 25 or whatever, if we repeat the random assignment many times, the slope of the sample regression line, sample meaning that little lowercase b, typically varies by about not 0.0094 from the true slope. By the way, these slopes are going to have weird decimals. Don't be freaked out by that. I think that that's a pretty good standard error. It's teeny tiny. So that means it's not too far off from the true slope, which is good. Okay, now our last one. So I'm going to go back to my page. I'm going to find r squared. I'm going to say square root of 0.09794. Does that make sense to everybody? So I got r squared off the thing and then took the square root, and then that is something, I did it earlier. It is 0.313. This is not very close to 100%. It's pretty far away from 100%. So I said weak, positive, linear, and I can say linear because, well, this scatter plot is crap. I don't know if you noticed. Anybody noticed that this scatter plot's crap? One of the things about CPM is they're going to give you a hard, like they're not going to make it easy. Normally, it would look like an actual line, but it just tells me that when we do the 12.3 B notes, we're probably going to fail to reject. So, anyway, there's a weak positive linear association. I kind of find that hard to believe. Maybe this fertilizer sucks. I don't know. Maybe there's confounding variables like the amount of sun or soil or quality of the coffee beans. Okay, here we go. Whew. Chapter 3 review, check, done. Construct and interpret a 95% confidence interval for beta equals the slope of the true regression line relating amount of fertilizer to yield per plant. I'm probably just going to copy off of this bits here, so 95% confidence interval for beta equals the I just had a really weird memory. My ex-husband is in marketing and he works for a um like a biotech firm, and he would always take their sales versus their ads or their marketing budget and make scatter plots and do linear regression. He did it in Excel, of course, not on a graphing calculator, but I remember him asking me for help. It was cool. I was like, I can help with the big boy real problem. Okay, now you guys see I just copied off the wording of this. It's a little bit different from the wording I gave you, but either way, we said all the stuff. We just said it in a little different order. Okay, plan. T interval for slope beta. Okay, so I'm using the word liner to help me remember the conditions. L stands for linear. Okay, what do I do to tell if it's linear? I go back to my resource page and I check the two graphs. Okay, these are terrible. The equal scatter's pretty good, but the linear bit is not great. I mean, I don't see a huge pattern either, so I'm gonna say it's fine, but this is just like all of the other situations that if it looks terrible, you just say that it's fine and move on with life because it's an FRQ. Now, they could get away with just giving you the residual plot because you can get the linear and the equal standard deviation condition off of that. But they were nice enough to give you both. You only need to cite one of them. I'm just going to say the scatter plot shows a linear pattern. Does that make sense? Okay. You could also say residual plot shows no pattern. Why don't we just put just in case you're looking back at your notes, you can say either one of those. I want you to notice something real quick before I move on. This is just my old chapter 3 brain coming back. Do you notice how I did not reference R here? I did not say R is 0.313, which says it's linear. I don't know if you guys remember back in the day, what was this, October? End of September, October, I said the calculator will still calculate R even if it's a curve. Remember? So you can't use numbers for this. You have to use graphs. Have to use graphs, have to use graphs, have to use graphs. what is the great part about that? That means that you have to be given graphs to look at. So anyway, okay. Independent. This one's random assignment. There's actually random sample and random assignment in this problem. I should note this for you. They went all out in this problem. They've got random sample, they've got random assignment. You could say each one about your 10% condition. I'm just going to go with random assignment because I'm lazy. Either way, I'm covered. Leave it to CPM and make it difficult. Okay, liner. What does N stand for? Normal. Okay, for normal condition, you check a histogram. Does the histogram look okay enough to you? Yep. That wasn't necessary. It's just for fun. Okay, let's talk about what equal standard deviation means. I'm going to talk about it with two pens. I'm going to look at my residual plot and I'm going to put a pen along the top and I'm going to put a pen along the bottom. Say, are those pretty evenly scattered? Meaning, is there no pattern where it's like getting further apart or getting closer together or anything like that? Does it just look equally distributed, pretty equally distributed across the thing? Yes, good enough. Okay, grab your calculator. So sample slope plus or minus T star times the standard error of the slope. Both of these two numbers are located here. So sample slope is right here, 0.0173. T star, let's do T star over here in this space. I almost wrote the T. Okay, degrees of freedom. Degrees of freedom is sample size minus 2. Sample size is 33 coffee plants. So degrees of freedom is 31. Let's practice this in our calculator because it's been a minute. Second vars inverse t parenthesis 1 minus 0.95 parenthesis divided by 2, 31. Always positive 2.04. Standard error of the slope was this number right here, which says standard error of the slope, 0.0094. That's where I was saying that you're never going to use these formulas ever. Not once, not one time. You're going to forget this box is even here because they're always going to give it to you in the output like that. Okay, so 2.04 times 0.0094, 0.02. Negative 0.0027. Zero 0.0373. All I'm noticing here, I'm hoping that you remember or you are picking up on the fact that this is going from negative to positive, which means that 0 is a possibility. Just saying. Just a reminder that your notation might look like that, this or this. That, I guess I was really off on my estimate of how